Scene script. Have you ever wondered how network engineers manage devices from a distance? Let's unravel the mystery. To start off, let's talk about remote access. It's a method that allows network engineers to reach out and touch devices from virtually anywhere in the world. It's like having a virtual hand that can tweak settings, run diagnostics, and even perform complex tasks, all without being physically present. This is crucial in network management, especially in large-scale operations where devices can be spread across multiple locations. Now, imagine doing all that without any form of security. It's like leaving your house's doors wide open. Anyone can walk in. This is where Secure Shell, or SSH, comes in. SSH is a protocol that provides a secure channel over an unsecured network. It's like a secret tunnel that allows network engineers to safely access and manage devices remotely. SSH isn't the only protocol that offers remote access. There are others, such as Telnet. However, unlike SSH, Telnet doesn't encrypt its connections. This means that anyone who manages to intercept the connection can see everything that's being transmitted, including sensitive information. It's like sending a letter in a transparent envelope. SSH, on the other hand, sends its letters in a sealed, opaque envelope, protecting its contents from prying eyes. The benefits of SSH extend beyond just security. It's also highly versatile. SSH allows file transfers, remote command execution, and even port forwarding. It's like a Swiss Army knife for network engineers, providing them with a wide range of tools all in one package. That being said, SSH isn't without its challenges. It requires careful configuration and management to ensure its effectiveness and security. However, the benefits it offers far outweigh these challenges, making it a vital tool in any network engineer's arsenal. So as we can see, SSH is a crucial tool for secure remote network management. But how exactly do we configure network devices to use it? Stay tuned. Now that we have a grasp on SSH, let's delve into the step-by-step process of configuring network devices for remote access using this protocol. First things first, to use SSH for remote access, it has to be enabled on the device. Most modern network devices come with SSH capabilities, but they may not be enabled by default. So it's essential to check whether SSH is turned on. If it's not, you can usually enable it through the device's command line interface using the command ipsh version 2. This command will not only enable SSH but also ensures you're using version 2, which is more secure than the previous version. After enabling SSH, the next step is setting up user credentials. This process involves creating a username and password that you'll use to access the device remotely. To do this, you can use the command username secret k. Remember, it's crucial to use a strong password to prevent unauthorized access. Now you might be wondering, how does the device know which users are allowed to use SSH for remote access? Well, that's where the line VTI configuration comes into play. The line VTE command is used to control incoming SSH connections. By default, most devices have 5 VTY lines numbered 0 through 4. You can configure these lines to allow remote access using SSH by using the command line VTY04, followed by login local and transport input sh. The login local command tells the device to use the local username and password for authentication, while transport input sh restricts the incoming connections to SSH only. Once you've set up SSH and configured the VTY lines, it's time to generate the RSA key pair that SSH uses for secure communication. You can do this using the command cryptokey_generate RSA, followed by the key size. A key size of 1024 bits is usually sufficient for most purposes. Last but not least, it's time to test the SSH connection. You can do this by trying to connect to the device from a remote system using an SSH client. If everything is set up correctly, you should be able to log in using the username and password you created earlier. Remember, while SSH is a secure protocol, it's still essential to follow best security practices. Always use strong passwords, regularly update your devices to the latest firmware version, and monitor your network for any suspicious activity. And voila! You've successfully configured your network device for remote access using SSH. But what if you need to transfer files? That's where TFTP and FTP come in. Transferring files between network devices is an everyday task for network engineers. But how can we do it securely and efficiently? Enter TFTP and FTP. These two acronyms stand for Trivial File Transfer Protocol and File Transfer Protocol, respectively. They're both internet software utilities that allow us to transfer files between devices within our networks. Let's start with TFTP, the simpler of the two. As its name suggests, TFTP is a trivial or basic protocol. It's lightweight and easy to implement, making it ideal for devices with limited resources or for networks with bandwidth constraints. However, it lacks the security and reliability features that its more complex sibling, FTP, provides. FTP, on the other hand, is a more robust and secure way to transfer files. It provides features like user authentication, data encryption, and error checking to ensure files are transferred accurately and securely. But these features come at a cost. FTP is more resource-intensive and can consume more bandwidth than TFTP. So, when do we use each? Well, TFTP is typically used in environments where simplicity and speed are paramount, and where security is not a major concern. This could include booting network devices or distributing firmware updates in a controlled internal network. FTP is used when we need to transfer files securely and reliably over the internet. It's the go-to protocol for transferring large files, managing website files, or any other situation where security and reliability are important. In a nutshell, TFTP and FTP are tools in our network toolbox. We use TFTP for its simplicity and speed, and FTP for its security and reliability. Like any tool, the key is knowing when and how to use each one effectively. TFTP and FTP are key players in managing files in a network. But how do we use them? Keep watching to find out. Now that we understand what TFTP and FTP are, let's explore how we can use them in our network. TFTP, or Trivial File Transfer Protocol, and FTP, File Transfer Protocol, are both used to transfer files in a network. Although they function similarly, they have distinct differences in their security and speed. Now, let's delve into how to set up and use these protocols in a network environment. To start, we'll need to set up a TFTP or FTP server. This is essentially a computer that stores the files you wish to transfer. It could be an actual server or simply a PC with server software installed. Once your server is ready, you'll need to install the TFTP or FTP server software. There are numerous options available, some of which are free, while others are paid. After the server software is installed, you'll need to configure it. This typically involves choosing the directory where your files will be stored, setting up user accounts, and determining the permissions for each user. Remember, FTP allows for more granular control of permissions compared to TFTP, which has minimal security features. Next, you'll need to set up your TFTP or FTP client. This could be another computer or device on your network that you want to transfer files to or from. Like the server, the client will also require software to be installed. Once installed, you'll need to configure the client by entering the server's IP address and the login credentials you set up earlier. Now, you're ready to transfer files. Simply choose the file you wish to transfer from the server, select the destination on the client, and initiate the transfer. You can monitor the progress of the transfer from the client software. Once completed, you should see the transferred file in the chosen destination on the client. With these steps, you can efficiently manage file transfers in your network using TFTP and FTP. Remember, while TFTP might be faster and require less resources, FTP offers more security and control. Choose the one that best suits your network's needs. So we've covered a lot of ground today. Let's briefly recap. We started off by delving into the world of remote access and secure shell, or SSH. We saw how SSH plays a pivotal role in ensuring secure remote access to network devices. It's a protocol that provides an encrypted channel, ensuring that our data remains secure while being transmitted over the network. Next, we moved on to the practical aspect of configuring SSH on network devices. It's not just about understanding the theory, but also about being able to implement it effectively. We then switched gears to explore the capabilities and functions of Trivial File Transfer Protocol, or TFTP, and File Transfer Protocol, or FTP. We discussed their role in managing file transfers in the network and how they can be effectively utilized. Now you're equipped with the knowledge to configure remote access and manage file transfers in your network. Tune in next time as we dive deeper into the world of network engineering.